Right, stream is on. Nice. Right, stream is on. I think I have to boost my volume a little. Nice. Right, stream is on. I think I have to boost my volume a little. Nice. Right, stream is on. I think I have to boost my volume a little. Nice. Right, stream is on. Okay. Now it's boosted by 5 decibels. Boost my volume a little. Nice. Right, stream is on. Okay. Now it's boosted by 5 decibels. Boost my volume a little. Nice. Right, stream is on. Okay. Looks like I had a feedback loop. Okay. We don't need any desktop audio. Put that to 10. Okay. Test. Microphone test. All right, great. Plus 10 decibels is a good number. Yeah. Let's start waking. So at the moment, no changes. So when I run the engine, this is the mesh that I load. I have mesh loading works ready. So I'm able to view this. It's like a 2D projection of the mesh, basically. I wonder if I could call this stream developing. C++ render engine. Brooks one. Whip stream. What? Yeah. Good enough. Okay, I think I want to show you how this rendering system works. I mean this mesh loading system. So I'm gonna open up Blender and I'm gonna add it. Yeah. Okay. Oops, it's a bit large. Okay, so I've got Blender out. So let's say I wanted to make a little mesh. Delete this. I'll make like because I don't have perspective projection on this CPP version yet, so it'll be like viewed from above. So let's make something recognizable. Do something like this. Just a little testing mesh, like a pyramid with some triangles, like so. Now that I have this little test mesh, it's nothing special. I can open a script. I got this Blender to JSON script. I call this test mesh 2. Then I just click it, run the script, ran. Now I can go take the Blender out. I'll just leave it there. So back into C++. Go here. I've got. So what I have to do here is I have to load the. I have two methods for loading. I have this load triangle count and then load mesh. So I need to so the mesh like spits out an array of these triangle structures. So I have to first like give it a array with the specified size of the triangle count. Otherwise, things break. So here we have TC, so it's like try count. Then I initialize an array, this T array with the TC, so it's like a array of triangles. The length of TC could be like 14 maybe. For example, if you have a 14 try-count mesh, you have 14 array elements. Then make a pointer to a new array, because this load mesh it doesn't return an array, but it returns the pointer to that array, so it's like the first element of the array. So here we can see like give it the triangles. Here we set the triangles with the data from the file, then we return triangles. So like it's triangles is an array, but what we're actually returning is like the pointer. So basically arrays in C++, it's like they're pointers. Arrays are pointers, basically, I guess. Yeah. But yeah, then we have where are we here? We have this triangle pointer triangles, which is just a pointer to an array, which I can then use like an array. Then I can load the mesh. Yeah. And just give it the try count and T this array. So now, because I made that new mesh in Blender, and I called it let me have a look. Desktop test mesh 2. So if I put it into my folder here, so if I change this name to test mesh 2, and then I would like to build it. Oh no, it's main. Oops. Yep. It's built. And now if I run the engine, you can see that's the same. That's the mesh that I made, but like viewed from above. Can probably see that. Move it like that. Yeah, you can see it. The mesh has been moved into the engine. Very cool. Very cool. Now I should color the mesh with its normal. Like visualize it a bit more. Or maybe, yeah, I could do that. Visualize it with its normal. Sure. Why not? So we're gonna make it so it looks like, if we just get the geometry node in Blender and just give the plugin normal, we should have a scene that looks a bit like this. Yeah, look a little bit like that. So let's get to it. I have to do that in rasterize. So I still have to project these if I want to get like true 3D. But at the moment I can just get the colors. So here I'm into this rasterize function. I'm giving, or this method, giving triangles and triangles both into projected and world tries. Because I want to, when I have the projection, after I do the projection thing, I still want to give to the rasterizer the world space triangle so I can like calculate the actual normals properly, like the world space normals. There's probably a better way to do it, but this is the way I've done it. So rasterize. Here I'm like giving the color of white. It's 255, 255, 255. So I want to get the normal. So it looks like I'll have to do a cross product thingy. So I'll have to add into this mathematics place cross product. I should probably, yeah, do a types. See this one. Yeah, types vec3 cross. It takes a types, give a constant types 3 v1 vector 1 and const types vec3 v2. I'm just gonna be lazy and just copy cross product thing from an old Python version instead of like figuring out the maths again. I'm just gonna where are we? There we go. So yeah, yes, from straight from Python. Okay, have to keep these not this, not, and it's actually almost done. Yeah, oh, that works straight away. I can just turn a types vec3 initialized with x, y, and z. does the sea lion? Oh, okay, interesting. So you can do that. Okay. Well, if it works, it works. Why not? Alrighty. Now we have a cross product. So we can do in the rasterize, we can get the so here we're in the rasterizer, we're looping through all the triangles. Then if checking with the point in triangle function, if the test point, TP test point, is in the triangle. So it is, then we calculate the normal as well. So we want the types normal equals math cross. Okay, so we want, we'll have to overload the subtraction operator as well, I think, most likely. Yeah, it's gonna complain. So let's go from, take I'm gonna call this try try, yeah, equals tries. Okay, call it p try. That do b minus a and then c minus a. That's complaining because I haven't overloaded that operator. So where are we here? We need operator, and I don't remember how it's done, so I'm gonna check out a tutorial. Overloading Geeks for Geeks, one of my favorite sites. Okay, so all I do, okay, so it's construct a kind of operator minus and vector 3 constant reference vector. Okay, so now I can do stuff. Okay. So I can do uh, vector 3 result or res and result x equals, let's see, x, so it's like our x minus spec x. Now let's do this for all of them. Okay. X, Y, Z, Y, Z, Y, Z. I can return res. Yeah, I guess, why not? Okay, so now down in the here in the normal, now the normal calculation should work. I still have to normalize it. I have to get the size. So I have to get a dot product as well. Okay, let's get the dot product. Where's my math? Where is the math names series? Okay. Load. Let's copy this. You. Then I'll do the same copy paste from Python. That actually works straight away. Nice. So if I remember correctly, well, I'll do the length. Load x3 len. Here takes a type v, and then what's it? So if you do a dot product between like this vector and this vector, gives the length squared. So we need square root. So return C++ have a nice easy square root. Standard library. It's in CMath, I guess. Yeah, CMath. Let's get CMath. Include CMath. Return standard square root. Dot v. Okay, now I have the length. Constant. Okay, so now we can normalize. So we need vector types, vector3, oops, not types. Normal is takes that. Then we return. Oh, I have to overwrite. I have to do overload the divide operator as well. Well, lots of stuff to do. Basic vector math. So I want the vector3 vector divided by vec3 length b. Now we have to overload that. So that. Yes, I'd like returns vector3. That's already, yeah. So I'm going to return vector3 again. Vec3 operator divide. And then plot reference number. What's different like that? Okay. Now do this result, and now result x equals x divided by none. Let's copy that. I can return this. Looks good. And normalize seems to work. So now we can go here. Normal equals math normalize normal. Okay, so now we have the normal for the triangle. Okay. Now in theory, what I can do is just take normal x times 255 z. But this might work. Yeah. Except it won't, because there's a narrowing conversion, so I have to make a function. That will work. Let's call it put in the math. This returns a int vec3 vec3 to RGB. It's like, was it RGB like 24? Whatever, doesn't matter. Type vec3b. Okay. Load R equals x times 255.0f. Do this for all of them. Is RGB x y z. Okay, now I have them as floats, and now I need to clamp with them, because if I can't have negative color color starts from 0, so it's like black. How did I clamp in C++? STD clamp. Nice. This in. I have to include algorithm. Okay. Include algorithm. Can check if my. Yeah, it does work. Okay, algorithm. So now here R equals standard lamp. Wow, that's very easy to understand. Which one of these is which? Aye. Okay, so first you give the number. So R. Low is 0.0. High is 5.0. Could join this with this, but I think it's more easy to understand this way. And now I can return a types invec2 R, G, and B. And we get narrowing conversion. But that's fine. Doesn't matter that it's converted. Oh yeah. Let's do that. Oh, but now it doesn't like it. If I cast it, let's do it. I'm lazy. I'm gonna leave it like that. I'm gonna complain, but it will probably work. All right. Now I don't need this anymore. And we get math. We can get vec3 to RGB, and then we give the normal. Normal. All right. Let's see if it works. Please compile. Nice. Ah, look at that. Look at it. It's exactly the same. It is quite beautiful. Let's. Isn't that great? Basically, the Blender view looks a bit light because it has this view transform. So if I put it to raw, it looks the same. Yeah. Like so. Look, it's identical. Normals work. Yes, world space normals work. All right. Now, if I was lucky with this mesh because it doesn't have any intersections, but this C++ implementation doesn't support any intersecting meshes yet. But I think that'll be for the next stream. I think this is good enough for now. Okay. I'm gonna end this now. Bye.